So good morning, good afternoon, good evening, wherever you are in the world. This is the ECOMFIN webinar series at the ESSEC Business School, and I'm Andrea Roncoroni, Director of the Center. So today, we welcome Honor Bobaitli. Honor is Professor of Operations Management at the Keelong Sian School of Business at Singapore Management University. He holds a PhD and a Master in Science in Management from INSEAD in France and a Master of Science in Industrial Engineering from Bilkent University in Turkey. His research interests cover a number of operations management related subjects, often lying at the interfaces of finance and operations. And these include manufacturing flexibility and capacity management, operational risk, operational decision-making in agriculture, sustainable operations, integrated risk management in global supply chains, and supply chain finance. Honor consistently publishes in top academic journals, including Management Science and Manufacturing and Systems Operations Management, as well in the Perspective Studies Journal, Foundations and Trend in Technology Informations and Operations Management. He serves as a senior editor of Productions and Operations Management and as an associate editor for MSOM, Manufacturing and Systems Operations Management. Right. Today, Honor is presenting a paper on stochastic capacity investment in the presence of production resource disruption and its implications for hedging. Thanks for joining us, and the stage is yours.
Thank you. You can go ahead and admit that person. Okay, Andrea, thanks for the invitation and thanks for the introduction. Happy to be here. Go ahead.
No, go on.
Okay, very good.
Yep.
Right. And I should admit this person too. All right. Okay, so the paper, okay, let's go back to one slide. Why it's not going back? Yeah. So the title of my talk is Stochastic Capacity Investment in the Presence of Production Resource Uncertainty and its Implications for Hedging, which I will explain each term in a moment. So this is a joint work with my colleague at SMU, who's an assistant professor, Gyun Fang. This is actually part of a research program that I started actually during my PhD. I graduated in 2007, it was a long time ago. That looks at capacity investment and manufacturing flexibility investment decisions in large-scale manufacturing companies, but considering integration of these decisions with financing and financial risk management decisions. I did publish a few papers in this area already, so this is my most recent work. I haven't even submitted the paper yet, so any questions, any feedback would be more than welcome. So just to give you an overall idea, I know some of the audience here is not non-academic, so you know, you can think of this as an aggregate capacity investment planning, right? So we are focusing on a manufacturing firm, right? Let's say they are trying to decide the capacity for a particular manufacturing plant over the next 5 years. It could be a single year, but over some time horizon, right? So normally the main uncertainty they would care because they're gonna use this capacity to produce products, and to make things simple, I'm gonna focus on a firm that just produces a single product, right? Because we will build a mathematical model around it, right? We would like to keep things a little bit less complex, right? So that's why we are focusing on a single product firm. So basically, when they make the capacity investment decision, they will later on use this capacity to make production, but they don't know exactly how much they're gonna produce because there will be some uncertainty about how much they can sell. You can think of this as a market uncertainty, price uncertainty, whatnot. So I'm gonna focus on demand uncertainty. That's gonna be the representative of my market uncertainty, okay? All right? So this is a very traditional aggregate capacity planning problem. You need to make your capacity investment decisions with respect to uncertain demand. And later on, once you have a better knowledge of how much demand you have, then you will make your production decision within the capacity that you have invested before, right? So that is the idea. That's the traditional capacity investment problem. Now, the first thing this paper makes as an observation, and which is obviously not very surprising, is that during the production stage, the firm, besides the physical capacity that they invested, they will also need some other resources, which I will call this as a production resource, right? So for example, this could be a physical resource, right? Where you need to buy components, for example, right? Or it could be a financial resource like a working capital, right? Because you need to finance your production decisions, your labor, whatnot, right? Again, to make things less complex, I'm just gonna focus on a single aggregate production resource, okay? Just to make it, make things a little bit less complex. Let me keep admitting at the same time. All right. Okay. Right. Okay. Now, the second observation this paper makes, which I think became extremely clear, I will give some examples during COVID time, when the firm is making the capacity investment decision, right? There is no certainty that there will be enough production resource to fully utilize this capacity. So there will be some uncertainty around this production resource availability, right? Like traditionally, we always, like firms always think that, look, capacity investment, whatever investment I make, in the future, I will for sure, right, have sufficient working capital, sufficient components to be fully utilize this capacity if I want to, correct? But as COVID has shown us the hard way, right, this may not be the case, right? Even though, you know, you assume that you will have enough components or enough working capital to utilize your capacity, maybe you will not be able to do that. So what this paper is saying is that you as a firm have to anticipate this and introduce this uncertainty in your capacity planning problem. Otherwise, you're going to invest in higher than necessary capacity, right? Assuming that you're going to fully utilize everything. Now, just to give you some examples, so I put here two popular press articles. Actually, one is from New York Times, the other one is from HBR, talking about how firms have actually experienced a lot of issues about raising financing, right? So the one on the left is during COVID time, right? You know, it was a difficult market for every firm. And the one on the right is about actually financial crisis in 2008, right? But this doesn't need to be only reasons, right? Think about it. If this manufacturing firm is a multi-divisional firm, if the headquarters is allocating you your operating budgets that you will use later on in the production stage, later on they may decide to take away the budget from you and allocate to another division, right? It happens like all the time, right? That's another reason why there could be some uncertainty around the availability of the financial resource. If we are talking about production resource being a physical resource like a component, right? There are many very good famous examples recent, like for example, in the automotive industry has been suffering from shortage of chips, right? For, I don't know, last 3-4 years now, right? And still not resolved yet, right? This one on the right talks about the plastics shortage. There was an Arctic blast in the Texas area in 2021 or I think 2021, which actually created a havoc in the petrochemical industry, which produces a lot of plastics. And there was a huge shortage of plastics, which is a common component that is used almost in all manufacturing industries, right? So, okay. So your component availability may vanish suddenly, right? Because of a disruption. And then you can actually find many more examples. I can actually talk 3 hours about this, right? So the recent Ukraine-Russia conflict, right? When it started, the energy prices, energy is also an input, right? As another production resource for your manufacturing environment. You need energy. So you have seen actually some manufacturing facilities like this guy, a cyanide maker in Eastern Europe, had to shut down the whole plant because energy price was so high, right? The margin was negative, so they couldn't really continue their operations, right? So when you think about it, if you have to shut down your production or scale it down for a certain period, right? Because of these kind of shortages, it is really important for the firm to think about this at the capacity investment stage, right? So that they don't necessarily invest in a lot of capacity, right? Okay, so that's the main core idea in this paper. Again, we can continue with the examples here, but I think you get the gist of it, right? Okay. So basically, now in the capacity investment stage, the firm has to consider both the uncertain demand for its product and uncertain availability of its production resource while making the capacity investment decision, right? So far, so good? Yeah. Now one key concept, which is very important for the story that I'm telling today to you is there any kind of dependence between this production resource availability and your product demand? Do they have any kind of correlation structure, right? And this is going to play a key role. So it really depends, right? So if we are talking about, for example, a local disruption, your production resource unavailability coming from a small fire in one of your suppliers, right? Probably it's not going to have an impact on your product demand, right? But if we are talking about, you know, global disruptions like COVID-19, for example, right? While the component availability is not there for sure, your demand is also affected in a way from the same disruption, right? So there exists a correlation, and sometimes this correlation could be positive, sometimes could be negative, depending on which type of manufacturing industry we are talking about. Again, going back to COVID-19, think about the beginning of COVID-19. Let's assume that we are producing medical masks, right? So the firm is definitely facing a component shortage because a lot of suppliers are shut down, but their demand is skyrocketing, correct? Right? So there is actually a negative correlation between your production resource availability and your demand. But if you are talking about automotive sector, at the beginning of COVID, also no demand for automotive, right? People stop buying cars and all. In a way, there is positive correlation, right? So in a nutshell, depending on the underlying factor behind the production resource unavailability, there can be some sort of a correlation between your demand uncertainty and production uncertainty, which needs to be taken into account. And that's going to be the core of what the story that I'm going to tell you. All right. So far, so good. Very good. Okay. More people. Oh, Fahmi.
Yeah.
Okay.
Access I gave you.
All right. So now, why am I actually presenting in a finance seminar? Because so far, what I told you all about operations, right? Now comes the financial side of it. Now, your production resource availability, as long as this resource depends on a financially hedgeable index, which I'll give you some examples in the next slide. What you can do is at the capacity investment stage, you can actually engage in these financial contracts to engineer the distribution of the availability of this production resource, right? So in a way, now we are talking about a joint capacity investment and financial hedging decision while facing uncertainty in the production resource and the demand, right? So what are the examples for that? For example, your operating budget can be dependent on a financially tradable index like asset prices, right? Something like that. Then you can actually sell a forward contract written on that index at the capacity investment stage, like, you know, long time before the actual production decision, which will help you to change the distribution of this production resource, right? Or if we are talking about, you know, production resource being a commodity component, right? Again, you can actually engage in long-term procurement contracts, right? Using the same budget, if you want to call it, right? You can change the availability of the component I mean, during, for example, Russia-Ukraine conflict at the beginning, the manufacturing facilities that actually stay afloat and even benefit from the conflict was the ones that were hedged, you know, long time, right? So, okay, you can do that, right? So that's the idea. So the research questions that I have for this paper: what are the optimal profit maximizing, in a way, capacity investment and hedging decisions in the presence of these two uncertainties? When you hedge, does it lead to overinvestment or underinvestment in capacity, right? How does production resource uncertainty, and here I'm gonna actually use production resource variability and the correlation between production resource and the demand to represent this uncertainty, affect the firm's optimal decisions, both the hedging and capacity investment, as well as firm's profitability, right? And the last question is about value of hedging, right? So of course, the firm may choose not to hedge at all, or to hedge whatever the optimal hedge is, and they're gonna make some money based on that. How does that value change in that production resource uncertainty? All right. So these are the questions that my paper answers. But of course, because this is a little bit of a shorter presentation, I'm not gonna discuss the answers to all questions. Yes, Andre, you have questions? Go ahead, please.
You have a distribution for the demand, which I assume might be continuous over a certain interval of values, right? And what about the distribution of the
production resource? Okay, very good. So I will actually talk about that in a moment, but for the general characterization of optimal decisions and all, we do not make any assumptions about specific distributions of these two, except for we assume they have a positive support, right? But when I would like to examine the impact of correlation as well as uncertainty, as well as production resource variability, of course, I need to introduce a bit more structure. And what I'm gonna do is I'm gonna go ahead and assume a bivariate normally distributed demand and production resource availability.
How does disruption enter this? You change the distribution from one distribution pre-event and post-event?
Actually, I am not really modeling the disruption per se. What I'm modeling is that you have a distribution of production resource, right, availability, which I am stating that this distribution is a result of potential disruptions that you have, right? So at the capacity investment stage, now you talk about over this 1 year, what could be the potential supply disruptions I may have, and how does it affect my production resource availability, right? So you do that analysis first. So you build yourself a distribution, right? And my paper actually starts there.
So that's good.
Now you go.
It's complementary.
Be complementary. Excellent, excellent, very good. So literature review. In operations, actually there is a very related stream of papers that's called inventory management in the presence of random capacity. So what these papers do is a little bit swapped version of what I'm analyzing. So they are looking at a firm investing in inventory, like procuring input, right? While facing uncertain demand. But at the same time, there is another uncertainty, which they call random capacity. They're gonna use this capacity to utilize the input and all, right? So basically what they call inventory, I call capacity. What they call random capacity, I actually call production resource, right? But it's just like a terminology difference, because my focus is on aggregate capacity planning. Now, what makes my paper different from this stream of papers is the fact that, except for one paper, which is Babbage 2010, where this paper actually just has one numerical example that examines what if these random capacity or production resource and your inventory or your demand are correlated. All these papers assume independent demand and resource availability or capacity availability, which is very important, because once there is independence, then the answers to my questions are very, very simple, actually, right? And even the hedging decision becomes a little bit trivial, which I'll show you shortly, right? That's why they also don't look at how financial hedging enter the picture, right? It becomes a little bit trivial, right? But my contribution to this set of papers is actually to consider a more general representation of this production resource uncertainty. And because of this general representation, then I kind of like introduce the financial hedging decision and how the correlation is playing a key role here, right? Another relevant stream, again, in operations, stochastic capacity investment in the presence of financial frictions. So in this case, you can think of your production resource as your budget or internal capital, right? Or external capital, whatnot, right? There are many papers in this area, but majority of these papers focus on financial constraints at the capacity investment stage. There is actually one paper only, which is my previously published paper, that looks at both capacity and production stages where you need to have raise financing, right? Where you have an operating budget for the production stage. But that paper basically, again, assumes independence between the availability and the demand. And that is why it doesn't really look at financial hedging and things like that. I mean, the questions that I'm trying to answer, that paper doesn't answer. It answers in a very different set of questions, looking at manufacturing flexibility, whatnot. All right. And obviously, there is a stream of papers both in finance and in operations that looks at financial hedging in conjunction with operational investments, right? So here my operational investment is capacity investment, right? In operations management field, majority of the papers introduce the need for financial hedging through risk aversion of the firm or the manager of the firm, right? Whereas the way I introduced the hedging decision is through this seminal paper, Fruit et al. 1993, it's a Journal of Finance paper, kind of thinking about having an internal capital constraint, and you need to raise financing from external markets. It creates convexity in your operational investments, right? Because of that convexity, you can actually hedge the availability of the internal capital. Very famous papers. Now, I can tell you they are famous because their main result is this. Once your financial risk, in my case, it's basically availability of the production resource, and your market risk, which is in my case, the demand, are correlated, they already show that you don't necessarily fully hedge, right? You may even don't hedge at all. Like optimally, you may prefer to have a volatile financial resource availability because this can help you to make more money in the operational market, right? So what I will do is I actually show a manifestation of this result in this particular capacity investment stage. But the main idea of correlation playing a key role, it's not from my paper, it is from this seminal paper. But of course, I actually show how it works in this particular important operational setting. Okay, right? Very good. So what I do is basically we do build a mathematical model representing this aggregate capacity planning problem in the most simple way possible, right? So that it is easy to tell my story. So we will focus on a two-stage stochastic problem, right? In stage one, the firm is facing uncertain demand and uncertain production resource availability and decides on capacity investment level and the hedging level, which I'll show you in a moment how this operationalizes. Then later on, the firm realizes the demand and the availability of the production resource, right? Together with the hedging decision that determines the actual availability of your production resource, because now you're executing your hedge, right? Then the firm decides the production quantity, obviously constrained by the capacity that is invested in the previous stage. It's actually a very traditional operational capacity investment, aggregate capacity investment problem, right? So I'm going to represent, you don't need to remember this notation. I'm going to represent the production resource using a tilde eta. This is eta, right? Tilde eta. I'm not very good with a Greek alphabet, but anyway. And then, so what I will do is to represent the demand uncertainty, I'm going to assume an inverse demand function where your price depends on your quantities. Here, the Q represents how much you produce, and more you produce, your price will decline, right? There are 10, 15 different models that you can pick actually to represent your demand, your market. But I think this is the most relevant one because if you have a shortage of input, right? What will firm do is they will obviously produce less. But if it is coming from a global shortage, like in the market, right? The prices for those products will be higher, correct? That is why I actually kind of use this quantity dependent price model. That's the main reason. And then we have unit capacity investment cost at the capacity investment stage and the unit production cost in the production stage, which I will normalize to 1. This one is actually without loss of generality, right? And the decisions are capacity investment level, K, capital K, production quantity in the second stage, Q, and H would be the hedge ratio. So we have actually, as I said, a 2-stage problem. And let's see. In the second stage, we are maximizing the production quantity Q. This is what you see on the as the objective is the revenues that you make minus the cost that you have. This is 1 times your production quantity. What matters is this: your production quantity is constrained by 2 things. One is the physical capacity that you invested in the first stage. And the second one is the availability of your production resource, right? And that is what you see as H mu eta plus 1 minus H tilde. So if H is 0, meaning there is no hedging, so that's going to be your production resource realization, right? If your H equals to 1, basically it is mu eta is the mean of your production resource. So you fully hedge, right? Anything between 0 and 1, there is a deterministic component, there is an uncertain component, all right? So that is how you engineer your actually cash flows. As Andrea asked and I answered before, for the sensitivity analysis, we assume eta, the production resource availability and the demand are bivariate normally distributed, obviously with correlation rho, okay? And yeah, this is a more closer look at how hedging works, right? So basically what hedging does is that when you decrease, I think it's easier to look at it this way, right? When H equals to 1, your production resource availability is actually even fixed in the capacity investment stage. It is mu eta, it's the mean of your production resource, expected production resource. As you keep decreasing your H, you are engineering the availability, the distribution of the production resource. You are having actually a mean preserving spread. So your expected availability is always the same, mu eta. That's why it's a fairly priced contract, right? A forward contract, right? But for example, when H equals to 0, no hedging, you have a complete uncertainty, right? As you keep increasing the H, you are reducing the variability. And then full hedging means it's just fixed. Understand? This is very critical. Is this clear how it works? It's very simple actually, but that's also the model that Fruit paper uses. All right? Very good. So how do you do it in practice? For example, H, if you are selling a forward contract, H represents the proportion of forward contract, which is a price of expected value of the index, right? If you're talking about this production resource being a commodity, right? H is the proportion of the component volume sourced through a fixed price long-term contract by using the same procurement budget. You can think of it this way, right? All right. But that is how I represent hedging. Are there other ways of representing hedging? Obviously, right? This is a linear contract, the simplest possible. But of course, you can have a non-linear contracts, options and all, right? You can do that too, but this actually works pretty well and it's easy to implement. All right. And this is already sufficient to tell my story. That's why I picked this one. All right. Okay, now the solution, we start by solving the second stage problem first, the production decisions. So there are two panels, but look at the panel on your right. So what this panel says is this. So here we have two axes. On the x-axis, we have the demand. On the y-axis, we have the production resource realization, right? It's actually pretty simple. Oh, we are making a lot of noise probably. I'm sorry, right? We forgot, yeah. Basically, if your demand is very low, you're not gonna produce anything, right? And there is actually an internal optimal solution that you would like to produce, right? That is given by, oops, what did I do? But if your demand is very high, then you're gonna be capacity constrained, right? And that's what you see on the right side, correct? But you can also be production resource constraint because you have two constraints, right? So basically, this picture is telling you that under what conditions you're gonna be constrained by your production capacity and you're gonna be constrained by the availability of the production resource, right? Okay, as simple as that. And why do I have panel A? It's because if you hedge, it is possible that, and if you invest very little capacity, you will never be production resource constrained in the second stage. That is why you only see three possibilities. Don't produce, produce up the capacity, or produce the interior optimal solution, but which is a special case, all right? Very good. So no hedging model, I would like to discuss a little bit about this because this will give you the intuition behind the optimal joint capacity investment and hedging decisions. That's the reason why I would like to spend time on this. And plus, to be honest with you, not every firm is using financial instruments, right? And they still want to understand how these uncertain production resource affect their capacity investment and profitability, which I can answer those questions as a part of my research questions. Now, basically what this proposition is saying is this: if your capacity investment cost is very high, higher than a threshold, you're not going to invest in any capacity. If it is less than this threshold, you're going to invest in an optimal level that is given by some first order condition, right? And the intuition behind first order condition is actually pretty simple. Again, the math is not that important here. So you need to, what is the value of adding one more unit of capacity? That capacity is usable for the firm in the production stage only when it is optimal to produce up to full capacity. And when does it happen? When the demand is sufficiently high and when the production resource availability is also sufficiently high so that it's not constraining you. So basically in this area, that the shaded area, so that expression captures this in a way, all right? That expectation is your marginal revenue. So no importance. Now, okay, now, here is, I think, the second most important result of my paper, right? The first most important result of my paper will come at the hedging, right? This is the second most. And it works because of this result. Now, we would like to understand what happens to firms' profitability if you increase the production resource variability. And to make things simple again, assume that we have a bell-shaped production resource distribution, right? When you increase its variability, what are you doing? You have the same mean, so you are spreading it out, right? So you're going to have more likelihood of low realizations and more likelihood of high realization, right? So how does it affect your profitability, the firm's profitability? Now, if the demand and the production resource availability are independent, so no correlation, which is exactly what is assumed in the whole literature, the answer is very simple. High production variability is bad news for profitability. Why? The intuition is also simple. When the production resource availability is low, you are negatively affected because you are constrained by the availability. When they are high, it's not as good news. I mean, normally it should be good news because you have a lot of availability, but because you are capacity constrained now, right? You can't produce because of your capacity. As simple as that. That is why higher variability is bad news. All right? Now, if these two are negatively correlated, the same result holds. Why? Again, think about the low production resource realizations. Now, not only production resource is low, because there is negative correlation, your demand is also high. So you are even more worse off because you actually need even more production resource, right? Understand? Whereas at the high realizations, right? Again, you can't benefit because of your capacity constraint. That's why this intuition can be easily extended to the case where you are, these two things are negatively correlated. When they become positively correlated, now things become interesting. Why? Again, think about the low resource production resource realizations compared to the independent case. Now they are not as bad because there is positive correlation. Now at these low realizations, your demand is also low, meaning you don't actually need that much. You see, the detrimental effect is a lot lower, correct? Whereas on the positive side, the benefits are a lot higher because your demand is also high. Understand? So it is possible that with positive correlation, higher production resource variability may not be detrimental, could actually be beneficial. And in fact, that is what, theoretically what we have proven. And I would like to just show you in this picture. So what you see here is on the x-axis, we have the correlation that ranges from -1 to 1. This is Pearson correlation. And on the y-axis, we have the capacity investment cost. So basically what this picture says that as long as your capacity investment cost is not very low and your correlation is not very high, high production resource variability always detrimental for the firm's profitability. That's why when I increase the variability, the profit is declining. I mean, it's just a representative figure, right? However, in this area, the shaded area, what we see is actually a U-shaped curve. So higher production resource variability is beneficial for firms' profitability for low levels of production resource variability, and beyond that threshold, it actually becomes, again, detrimental. All right? Okay, and correlation, again, is a key for that. For this result to happen, you need high correlation and low low capacity investment cost, because that capacity investment cost also affects your optimal capacity investment decision, which helps you to benefit from high realization. So that's the idea, okay? So this curve and this particular threshold will be extremely important for the hedging decision, which I will explain now, okay? But that's the second key result of this paper. High production resource variability can actually increase profitability, specifically when the correlation is high, capacity investment cost is low, and production resource variability itself is low enough, right? And we do this, obviously, kind of characterize this mathematically. All right. All good so far? Excellent. Now the hedging model. So what is hedging model? again, coming back to this one, basically the previous model I showed you is implicitly assumes that H is 0, so no hedging, right? Now, I actually decide the hedging ratio, H, between 0 and 1, together with the capacity investment decision. And remember that my H engineers the distribution. H equals to 1 makes the production resource availability deterministic. H equals to 0 means no hedging at all. You have the same distribution. Anything in between, you are basically having a mean preserving contraction. All right? So you can go ahead and solve the optimal joint capacity investment and hedging decisions. Obviously, it looks a lot more complicated than the previous model, right? So let me show you on your left hand side, what you see is the optimal capacity investment decision, whereas on the x-axis we have the capacity investment cost.
Is analytical or
analytical
is implicit in an equation, and then you solve numerically, or you
this is actually, let me tell you, okay, here what happens is this, right? Let's start with, let me explain. Let's say your capacity investment cost is very high. Then you're going to invest in very little capacity, correct? If you invest in very little capacity, then probably by full hedging, you will secure enough operating budget or production resource to fully utilize that capacity, okay? That is why on these cases, you're gonna fully hedge, all right? Just now I'm moving to the full hedging. Now, this is the capacity unconstrained, production resource unconstrained level, but it is actually implicit, obviously, right? I can't characterize this in clause 1, but it's implicit, right? Right? As you actually keep reducing the capacity investment cost, slowly, you are increasing the amount that you are investing, right? And still, up to certain level, you continue doing full hedging because that is still sufficient for you. Now, if the capacity investment cost is very low, right? You want to invest in a lot of capacity. But if you do full hedging, right? The available production resource, although deterministic, not good enough. It's going to be very constraining. So what you do is you basically optimally do not hedge at all so that you leave it like at least at high states where I have high production resource availability, I can go ahead and utilize this capacity that I invested, which is really high. Okay? That is why basically when your capacity investment cost is really low, you invest in the same capacity with the previous model that you assume no hedging, and you optimally choose no hedging. And in between these two, you partially hedge. You choose something between 0 and 1. Okay? And these decisions obviously depend on these capacity investment cost thresholds, which we can characterize, and they critically depend on the correlation between the demand and the production resource availability. For example, if the correlation is 0, meaning they are independent, or correlation is negative, we already established that higher production resource variability decreases the profitability, right? Which automatically means that you're gonna always fully hedge. Which means that these two thresholds that you see in my figure, C under bar and C over bar, they become 0 under these correlations. So they become positive when correlation is sufficiently high, which will be my next result. Okay? Is this clear? Right? Right. Okay. And then what I would like to focus is partial hedging. So as you can see, there are actually 3 different hedging policies: full hedging, no hedging, or something in between. To be honest with you, in operations literature, right, when people, scholars, try to optimize hedging decisions, they generally focus on this. They implicitly say either we fully hedge or we don't hedge at all. They still optimize, but just considering these 2 options. They know that partial hedging is possible, but they kind of like implicitly not look into that because it's horrendously difficult to actually characterize the partial hedging policy, right? And you can understand why. Look at this. Now you have a joint capacity investment and hedging decision that is characterized by two implicit expressions, right? You can make sense of it, obviously, but if you want to do further analysis, it becomes really, really difficult, right? That is where our key result will come in. This is the result that I really like the most about this paper, is this. If you assume bivariate normal distribution, then you can further simplify the partial hedging decision in such a way that capacity investment and hedging decisions, they decouple. So how do they decouple? Let me show you. Again, this is not important. Remember this figure, right? I showed you that within this region, high production resource variability is bad news for profitability. Whereas in this region, high production resource variability is good news first, then bad news, correct? So what is the implication for hedging? The implication is this. First of all, here you will always fully hedge. You want to remove the uncertainty because high uncertainty, high variability is bad news. That is very simple, right? How about here? In this part, it's not obvious, right? Because some benefits, some reduces. And that part, basically, now let's have a closer look. So what do we see here? As you can see, firm's profitability first increases in production resource variability, then decreases. Let's call this top point where it maximizes a threshold of production resource variability. And that depends on actually capacity investment cost and correlation, right? Now, if your actual production resource variability is less than this threshold, you are actually in the increasing side, right? So what do you do now? Because you are benefiting from higher variability, you optimally do not hedge at all. So this is the characterization of no hedging region. How about if your actual production resource variability is on the right-hand side of this threshold? Now, high variability is bad news, right? But it is good news up to that threshold, right? Correct? So what you will do is there a way that using the hedging, can I bring my actual production resource variability, incorporating the hedging, to that particular maximizing level? And that would be the key in constructing the partial hedging decision. Your optimal partial hedge given by this expression that involves that particular threshold. Now, if you look at, think about the variance of, I think it's the easiest way, the variance of your actual production resource availability. Now, when H equals to 0, the variance of your production resource availability is just the variance of the actual distribution, right? That is the sigma eta square or standard deviation. Think of this way. Now, when you look at the variance of this distribution after you do the optimal hedging, you can show that this variance or its standard deviation actually equals to the profit maximizing level. Understand? So in a way, you hedge in such a way that you always bring the production resource distribution standard deviation to that profit maximizing level. That's why it decouples. All right. But when I say decouple, of course, it does depend on the correlation and the capacity investment cost. All right. And yeah, you have a question? Of course, go ahead.
You use a linear edge, right?
Yes.
Risk neutral probability equal to historical probability.
Yes.
So no risk premium. Okay. Because otherwise you might have a variation in the profit due to the speculative side.
Correct. That is true. But actually, again, going back to Fruit et al. Framework, right? What they do is they also allow this hedge ratio to be negative. And they say that this is actually speculation, right? Because now, when you have negative, obviously you have a higher than eta distribution, right? But then then there are like credit issues because you don't have enough capital to issue, right? That is actually a criticism of that paper. They acknowledge it at the footnote, but again, I don't need that to tell my story, right? So that's why I'm not looking at that part. Okay. All right. Very good. Yeah. So basically, this is how the optimal partial hedging decision looks like. Now, on the left-hand side, you have the production resource variability versus profit. Here, you have the production resource variability versus the optimal hedge. In the increasing side, you optimally do not hedge at all. In the decreasing side, you keep partially hedging, but at the same time, keep increasing your hedge ratio in such a way that it converges to full hedging actually when it is sufficiently, like when it actually asymptotically, to be honest with you, like to be more mathematically precise. All right. So you create this partial hedge in such a clever way that you always bring it back to that profit maximizing production resource variability level. All right. Very good. Now, then what is the impact on production resource variability when we do optimal hedging? Now, it is very well known that when you fully hedge, you remove the impact. So it doesn't affect you, right? That's very well known, very obvious, right? When you do no hedging, so you are basically you are optimally choosing not to hedge at all. It is because your profit is actually increasing in production variability there, right? And that's why profit increases in resource variability. Now, when you do partial hedging, this is the part that is not obvious. It acts as if it is a full hedge in the sense that your profit becomes independent of production resource variability, as if it is full hedging. Because as variability increases, you keep updating your hedge. You keep changing the partial hedge so that it absorbs the effect. All right? So that's, again, a key result of this paper. Of course, it does depend on the bivariate normal assumption. With other distributions, you can't prove this, right? And in fact, it's not going to be true, to be honest with you, right? But because you are optimally constructing the hedge in such a way that basically it absorbs the effect. They closed down the air cons. Did you realize?
So we're gonna survive for
another 5 minutes. Okay, yeah, no problem. Just saying, right? Because the guy said I will tell them not to do it. Right? There you go. For your information for the next round. Okay. Okay, this one I can skip because I didn't talk about. Oh, but what I would like to highlight, okay, is here. Now, remember, uncertainty, production resource uncertainty are represented by two parameters. One is the variability. The other one is the correlation between the resource availability and the demand, right? What I have shown you is that the hedge is optimally constructed in such a way that in the partial hedging region, profit becomes insensitive to variability. But is it the same for correlation? No. It's somewhat intuitive, but what happens is that as correlation changes, right, your optimal hedging decision doesn't fully absorb the correlation effect. So your profit is still being affected by change in correlation. Now, when you are fully hedged, you don't care about correlation because there is no uncertainty of production resource. When you do full no hedging and partial hedging, you can show that, you can prove that high correlation is actually good news for profitability, right? Why high correlation is good? Because high correlation means when production resource availability is high, your demand is also high. That's good. And when production resource availability is low, which is bad, but demand is also low, so not so bad. You see what I mean? If it is the other way around, if negative correlation, it's really, really bad, right? Because you have high availability of production resource, but you can't benefit because there is very low demand. And when there is low availability, you are so much negatively affected because there is so much demand, right? Understand? All right. And the last point is value of hedging. Now, if I compare the profit with my optimal hedging, right, with profit where I don't have hedging, right, how does the difference, which I can call value of hedging, changes in the production resource uncertainty, right? So what you can show is that, again, these are all illustrative figures, but not surprisingly, I think, higher the production resource variability, higher the value of hedging, right? That is obviously true for full hedging, but even partial hedging, it continues to be true because, again, partial hedging fully absorbs the effect, whereas when you don't hedge, in that region, you are negatively affected, right? And in the no hedging region, you don't have value of hedging because you optimally do not hedge, right? So what is interesting is obviously the effect of, what happened? Correlation, right? Something that actually there is really, to the best of my knowledge, there is no paper that looks at how the correlation between the financial index and a market uncertainty affects the value of hedging. Even Fruto et al. Paper doesn't look at that. You have? OR paper? Good. Then I will cite it. Okay? Excellent. So what it shows is that here, high correlation actually reduces the value of hedging. In fact, what happens is that high correlation is good news without hedging and with optimal hedging. But because value of hedging decreases, this means that it is more good news when you don't hedge at all, in a way, right? Optimally. When you don't consider hedging. So when you optimally hedge, even though you can't completely remove the effect of correlation, you still somehow reduce its impact. That is why value of hedging is decreasing correlation. What does your paper find?
It's a correlation not between demand and production resource, of course, because you're the first one doing this, but we're talking about the correlation between the demand or any other non-financially insurable source of risk and the underlying asset of the derivative that you're using for the purpose of coping with that risk.
To hedge the demand.
To hedge the demand.
Okay, got it. Understand what you're saying. Correct, correct.
Even a vector. Yeah.
Correct. But in that case, you
find also the notion of value of hedging, because this is controversial. There's not a single definition of. So we define the value of hedging in terms of certainty equivalence.
I see.
Because it depends on the target you use.
I know, but for certainty equivalent to make sense, don't we need kind of a risk aversion?
Yeah, we use a mean variance
exactly, but
target.
Correct.
And we can interpret the certainty equivalent in
Excellent.
dollar value.
Very good. So basically, as I told you, generally speaking, there are two main reasons how you can introduce hedging into an optimization framework. You just need to, you need somehow some sort of convexity that creates a cost for you for the variability of your cash flows. Now, one way is very commonly used is risk aversion. Because when you are risk averse, you have a concave utility. By definition, you do care about, you are worse off by higher variability, right? What I do is the other approach, the cost, which is a convex cost, but it's the same. You know, eventually, the way they work is the same. Again, it's a choice, right? I chose this one. That's why I don't introduce a risk aversion. I don't need to introduce risk aversion in my model. Now, in your case, obviously, it's a different manifestation, right? So you are hedging your demand exposure because of the correlation between the financial index. Again, very common approach, even in operations literature, right? To use, right? Like the papers that I have here, right? So mine is a little bit different. That's why the result is also a little bit.
Corporate finance
exactly.
approach, and the other is more financial engineering.
Exactly. Right? So I would say this is like, if you want to call it an extension, I wouldn't call it an extension of Fruit et al. Paper, but it's more like a more operational version of the Fruit et al. Paper. Is because what operations here being a canonical capacity investment problem, which there are like million papers on that, to be honest with you. I've written a few of those myself too. Right? Okay, is this clear? So these are the main results of my paper. So what are the key? I think timing is good, so I can yeah, I can stop here. I think, right? I'll just leave it here now.
Thank you very much, Honor, and thanks to all the participants here and there online. So next meeting is going to take place on Tuesday, April 23rd at noontime Paris time zone, and Femi Tenrisever, who is, by the way, here attending this webinar from Bilkent University in Turkey, is presenting integrated management of inventory, labor, and financing under negative demand shock.
It's a very good paper.
Yeah, okay, great. Thanks again, and
Thank you. Thank you.
Thank you, guys. Thank you.
Bye,
Thank you,
Christina.
Bilge.
Bye, Felix.
Thank
Bye.
you.
Bye. Bye. Thank you.